Hello guys, welcome to Unit 13 of our lecture for Advanced Database 2. Today our discussion is about NoSQL. So NoSQL, originally referring to non-SQL or non-relational, is a database that provides a mechanism for storage and retrieval of data. It is modeled in means other than the tabular relations used in relational databases. Such databases came into existence in the late 1960s but did not obtain the NoSQL moniker until a surge of popularity in the early 21st century. They are used in real time web applications and big data, and their use are increasing over time. They are sometimes called not only SQL or not for NO only SQL to emphasize the fact that they may support SQL like query languages. A NoSQL database includes simplicity of design, simpler horizontal scaling to clusters of machine, and finer control over availability. The data structures used by NoSQL are different from those used by default in relational databases, which makes some operations faster in NoSQL. The suitability of a given NoSQL database depends on the problem it should solve. Data structures used by NoSQL are sometimes also viewed as more flexible than relational database tables. Many NoSQL stores compromise consistency in favor of availability, speed, and partial tolerance. Barriers to the greater adoption of NoSQL stores include the use of low-level query languages, lack of standardized interface, and huge previous investment in existing relational databases. Most NoSQL stores lack true acid or atomicity, consistency, isolation, and durability, which, as you may remember, has been discussed as one of the properties of a relational database. But a few databases such as MarkLogic, AirSpike, Faircom, Google Spanner, Schemas, and OrientDB have made them central to their designs. Most NoSQL databases offer a concept of eventual consistency in which database changes are propagated to all nodes so queries for data may not return updated data immediately or might result in reading data that is not accurate, which is a problem known as tail reads. Also, some NoSQL systems may exhibit loss writes and other forms of data loss. Some systems provide concepts such as write ahead logging to avoid data loss. For distributed transaction processing across multiple databases, data consistency is an even bigger challenge. This is difficult for both NoSQL and relational databases. Even current relational databases do not allow referential integrity constraint to span databases. There are few systems that maintain both Open XA standards and ACID transactions for distributed transaction processing. In general, there are three different kinds of database management system. The one that we have studied earlier and in the last semester, which is the relational database management system. And then there is also what we call an OLAP or online analytical processing, which is usually used for data warehousing. And then also lastly, which we will tackle today is NoSQL or not only SQL. NoSQL databases are different than relational databases because in relational databases, you need to create a table, define the schema, set the data types before you can actually insert the data. In NoSQL, you don't have to worry about that. You can insert update data on the fly. One of the advantage of NoSQL database is that they are really easy to scale and they are much faster in most types of operations that we perform on database. There are certain situations where you will prefer relational over NoSQL. However, when dealing with huge amount of data, NoSQL database is your best choice. Limitations of relational databases. We need to define structure and schema of the data first, and then only we can process the data. Number two, it provides consistency and integrity by enforcing ACID properties. There are some scenarios which Further, this is useful like banking system. However, in most other cases, these properties are significant performance overhead and can make your database response very slow. And then lastly, most of the applications store their data in JSON format, and relational databases don't provide you a better way of performing operations such as create, insert, update, delete, etc. on this data. On the other hand, NoSQL store their data in JSON format, which is compatible with most of the world's application. So this is an example of a JSON string. We have notice it is placed inside curly braces, and then we have a key, and then it is separated by colon, and then we have a value. So notice this is a key, and then this is a value. It is similar to the concept of array. So one particular JSON string can contain one data about a particular um, person, object, or any other information. So in this JSON format, we have three properties: the name, the age, and the car, each property having a particular value. What are the advantages of NoSQL? First is high scalability. They use sharding for horizontal scaling. Partitioning of data and placing it on multiple machines in such a way that the order of data is preserved is called sharding. Vertical scaling means adding more resources to the existing machine, whereas horizontal scaling means adding more machines to handle the data. Vertical scaling is not that easy to implement, but horizontal scaling is easy to implement. Example of horizontal scaling databases are MongoDB, Cassandra, etc. The SQL can handle huge amount of data because of scalability. As the data grows, the SQL scale itself to handle that data in an efficient manner. And then also we have high availability. Auto replication feature in NoSQL databases makes it highly available because in case of any failure, data replicates itself to the previous consistent state. Now, what are the disadvantage? First, narrow focus. It is mainly designed for storage, but it provides very little functionality. Relational databases are better choice in the field of transaction management than NoSQL. Next, open source. There's no reliable standard for NoSQL. In other words, two database systems are likely to be unequal. Management challenge. The purpose of big data tools is to make management of large amount of data as simple as possible. But it is not so easy. Data management in NoSQL is much more complex than a relational database. NoSQL has a reputation for being challenging to install and even more hectic to manage on a daily basis. Next, GUI is not available. GUI mode tools to access the database is not flexibly available in the market. Fifth, backup. It is a great weak point for some NoSQL databases like MongoDB has no approach for the backup of data in a consistent manner. Lastly, large document size. Some database systems store data in JSON format, which means that documents are quite large. So we have big data and big network bandwidth and issues with speed. And having the scripted key names actually hurts since they increase the document size. Types of NoSQL database we have here five, but there are actually more types of NoSQL databases. But the three most common are key value store, document based, and tabular based. We also have column based, which is based on tabular, and then we have graph based. When should NoSQL be used? When huge amount of data need to be stored and retrieved, the relationship between the data is not important, the data changing over time and is not structured, and support of constraint and join is not required at the database level. Also, the data is growing continuously and you need to scale the database regularly to handle the data. Now, this is a diagram comparing relational against NoSQL. You notice relational database is focused on functionality. but it gives less performance. Whereas NoSQL is focused on scalability and performance, but it gives less functionality. Key value store NoSQL. They are actually pretty straightforward. A value which can be basically any piece of information is stored with a key that identifies its location. In fact, this is a design concept that exists in pretty much every piece of programming as an array or map object. The difference is that it is stored persistently in a database management system. So this is an example. We have a key, example city, state, country, and then we have a value. For city, Denver; for state, Colorado; for country, USA. What makes key value store so popular is that the information is stored as a sort of an opaque blob rather than as discrete data. As such, there is really no need to index a database to make it perform faster. Instead, it performs faster on its own due to the way it's structured. Similarly, it doesn't really have a language of its own, simply relying on simple get, put, and delete commands. If you have programmed before, this get, put, and delete commands have been tackled in your earlier programming language, particularly when you are dealing with lists, arrays, and the like. Of course, this comes with the downside that the information you get from a request isn't filtered. This lack of control of data can be problematic under certain circumstances, but for the most part, it's worth the exchange. Since key value stores are fast and reliable, most programmers work around any filter control issues they may come up again. So the benefit of key value, okay, vertical and horizontal. So when we say vertical, we increase the resources used by the server. When we say horizontal, we increase the number of server. Scalability. One of the biggest benefits compared to a relational database is the fact that key store values are infinitely scalable in a horizontal fashion, which is a big advantage to complex and larger databases. More specifically, it manages this through partitioning and replication. It minimizes ACID guarantees by going around things like low overhead server calls. No simpler querying. Querying in general is really not doable with key value stores except in specific cases when it comes to querying keys, and even then it's not always possible. Therefore, in such cases as sessions, profiles, shopping carts, and so on, key value makes it cheaper to handle since it's just one request to read and one request to write due to the blob-like nature of how the data is stored. Similarly, concurrency issues are easier to handle since you only need to resolve one key. Mobility. Since they don't have a Keurig language, key value stores are easy to move from one system to another without the need for a new architecture or changing code. As such, moving from an old OS to a new one doesn't cause a severe disruption as it would with a relational database. When to use key value? Traditional relational databases are not really made to handle a high volume of read-write operation, which is where key value store shines. Since it's easily scalable, key value can handle thousands upon thousands of users at any given seconds. Additionally, with a built-in redundancy, it can handle lost storage or data without any issues. As such, there are a few situations where key value shines. Number one, user preference in profile stores. Number two, large-scale session management for users. Number three, product recommendations, such as in e-commerce platform. Number four, customized ad delivery to users based on their data profile. And number five, data cache for rarely updated data. There are also a variety of other situations where key value does well. For example, due to its scalability, it often tends to get used for big data research. It also works well for session management, whether it's web application or MMO games and managing individual player session. Another great use is for temporary and seasonal surges in purchasing on platform. For example, during holidays such as Christmas, Thanksgiving, and so on, rather than investing heavily on infrastructure that will not be used year round. The quick and easy scalability of key value allows stores to purchase one or more temporary shards to help process these seasonal surges. So, example of popular key value databases, we have Amazon DynamoDB, the most widely used key value store database. It was the research made into DynamoDB that really started making NoSQL really popular. We also have Airspike, Berkeley, Cowpage, Memcache, React, and Redis. There are also other examples. You can just find them on the internet. The real brilliance of a key value store is that it's simple. While this can be a double-edged sword, especially when it comes to more complex things such as financial transactions, it's purpose-made for bridging gaps of relational databases. By using combination of both relational and non-relational, we can even make a more efficient pipeline, whether it is for data analysis or dealing with users. Lastly, document-oriented databases. Document-oriented databases or NoSQL document store is a modernized way of storing data as JSON rather than basic column rows. The storage lets you retrieve, store, and manage document-oriented information used by the likes of MongoDB, Cosmos DB, DocumentDB, PostgreSQL, etc., etc. The semi-structured data lets you handle challenges that are harder to grip with a relational database. When a database requires a change in its model, relational databases requires developer to request the database admin to step in. With more people in the chain, newer companies still in rapid growth can hardly afford these inefficiencies. A rigid data structure with columns and rows where one column insertion affects the whole table is ill-fitted for agile software development which needs adaptable processes and faster software shipment. Then lastly, our DBMS can be oversimplified. A flat data structure, columns and row, is not a natural way to store data. Dividing it into columns is less flexible than more complex data schemas seen in document-oriented databases. Centered around JSON-like documents, Document Store makes a natural and flexible solution for developers that can work faster with agile software with superior developer productivity, which is why the document data model in modern NoSQL databases has become a popular alternative to tabular relational database. XML and graph databases. A quick word on this too. XML is a subclass of document-oriented databases, but streamlined for XML documents. Graphs are similar thing, but with an additional layer or relationship, adding a document linkage function for fast transversal. Note that most XML databases are indeed document-oriented. How document databases differ from relational, they are significantly different in function to relational databases. Relational databases store data in separate linked tables defined by the programmer, allowing single objects to be spread across several tables. But in document databases, all information for a given document or object is stored in a single instance. There's no need to do object relational mapping. Document databases are faster for this reason, although this is incumbent on how you use it. These are the pros or the advantages of document databases. Flexible schemas. Rather than the tabular model, document stores have a dynamic self-describing schema adaptable to change. No need to predefine it as the database. Values and fields can alternate through different documents. We can modify the design at any stage without fundamentally disrupting the structure. Also, it is better for agile developers. They are faster and easier for developers. The objects in your code can be mapped to the documents, making them more intuitive to handle. Powerful querying. Query in a flexible way with expressive query language and multifaceted indexing feature. The query language have comprehensive abilities letting you deal with data however you think best. Full-time aggregation and ad hoc queries and indexing are deep way of processing, modifying, and retrieving your data. Asset transaction let you retain your guarantees you're accustomed to having in SQL databases, whether it is a manipulation of data in single or in multiple shards. Widely compatible, JSON documents are used in every corner. Distributed systems, they increase how massively scalable and resilient your data is. Are documents easier to work than tables? Document databases is practical, intuitive modeling that reads faster than relational model. If you add superior indexing, this is boosted further. Many developers choose Oracle and SQL over NoSQL because they think rows and columns read faster than documents. Document databases have been consuming more of the market share once occupied by relational databases because developers are wisening up to the truth. Relational database would be faster if all the info needed per query was contained in a single row. However, in reality, the query has to search across several relations, retrieving data across different tables, then parsing it back together before spitting out the result. Whereas document databases contain all the data you need in one location. All you need to do is query it, massively reducing complexity and boosting performance. Pros and cons of document stores. On the pro side of things, the main thing to know is that relational databases require the same fields to exist for each information and entry. When information is available or unavailable, the cell is empty. However, it still needs to exist in the database. Document-oriented databases have much more flexible structure, not requiring consistency, and even large amount of structured data can be handled by the database. Also, new information can be more easily integrated. No need to add new information fields to every dataset. However, document databases don't have quite the relational capacity. In fact, document stores aren't well suited to being referenced that way. This is the main con or disadvantage to document store. As long as you do not try to use relational aspects, such as linking documents together by fields, then you won't need to deal with that, will likely become very complex and finicky. A relational database is much more suited to data volumes with high level networks. There you have it. This is our introduction to NoSQL.